All right, Algebra 1. Let's see. It's going to be your lesson. We'll take notes. So Algebra 1. This is going to be section 4.2. Writing equations in point slope form. All right. Okay, so you should put your name on here, the date, the period. You're turning this in for credit. So, what is point slope form? So, point slope form is a way of writing the equation of a line. And it looks like this: y minus y1 equals m times x minus x1. That's what point slope form is. We've been doing slope intercept, which we will continue to use for some of the problems today. Slope intercept is y equals mx plus b. So you'll notice that they both have a slope. But this has a x1 and a y1. So this is the y coordinate of a point that you know. And this is the x coordinate of a point that you know. So that's what we're going to be going for. Now, make sure that when you read the questions that you notice what form they want the final answer in. So we're going to be using point slope form on probably every problem day. But some answers are going to leave in point slope form, and some we're going to change. So example 1 says, write in point slope form write in point slope form of the line that passes through -8, 3 and has a slope of 1/4. So we're going to try and write this equation. So, we're trying to get point slope form for the final answer. Okay. So the slope equals 1/4. So you're right, m equals 1/4. And we have a point, -8, 3. Now the point gives you an x1, y1. Gives you an x and y coordinate for the line. Now, what might be good is to go ahead and write the equation, the model for point slope form, y minus y1 equals m times x minus x1. Write it like right where you're going to do your work so that you don't mess it up. So, we have m, we have y1, we have x1. So we're going to just plug those things in, substitute them in. So y minus y1, that's 3, equals the slope is 1/4. X minus x1 is -8. I like to put an extra set of parentheses around it when there's double negatives and stuff, just to make sure. And then, of course, minus minus becomes plus plus. Double negative becomes a positive. Y minus 3 equals 1/4 x plus 8. And this is point slope form. And that's your final answer. Just leave it like that, because they said point slope form the directions. A lot of times, though, they're going to tell you to do more. Example 2. Okay, directions will say write the equation in slope intercept. So when you're reading this, you're like, ooh, I need slope intercept, which is what we were doing before. I'm going to give you a picture of the graph, which we've done these kind before. So you would be given this picture already done. And so 1 comma 2, I'm going to give you this point on the line already. And then we'll do 3 comma negative 2. So we'll say that that point is known. And these would be labeled already in the picture. And then it's going to be a straight line connecting them. So that would be given to you. So slope-intercept form is y equals mx plus b. And the m, well, the m is the slope, right? So we know we should get a negative slope, right? Because it's going downhill, left to right. Better get a negative slope. And slope, one of the ways we think of it is rise over run. And if you have a picture, you could just literally count the squares. Now, it's going from left to right. It's going down 1, 2, 3, 4. So it went down 4, negative 4, and then to the right 2. That's positive 2. So that's rise and that's run. Negative 4 over 2. And then we could simplify it. So we get the slope. Now, in the previous section, the y-intercept in this kind of problem would be obvious. It'd just be on the picture. And this one is not on the picture. So we can't use this equation to start with. We're going to use point-slope form. Okay? So we need to start with point-slope form. And either point, in fact, I'm going to show you both ways. That either point could be your x1, y1. I know, I might, yeah. So let's go with 1 comma 2 as our x1, y1. And so then we're going to do point-slope form. So point-slope form is y minus y1 equals m times parentheses x minus x1. So I'm going to plug them into that. Y minus 2 equals negative 2 times x minus 1. And that's point-slope form. That's good. That's done. But they want slope-intercept. So what we need to do is take this and keep going with it and get y by itself. Solve for y. Does it have any parentheses? No. So the first thing I do is get rid of parentheses by distributing. Negative 2x plus 2. Be careful. Negative times negative is positive. And then to get y by itself, we're going to add 2 to get rid of the minus 2. What do we do once I go to the other side? And we're going to get y equals negative 2x plus 4. And this is your final answer in slope-intercept. Now, just to prove to you, we could have used the other point. We could have used 3, negative 2 and called it x1, y1. Okay, let's see how it works out. Just to compare it. Y minus negative 2 equals m is still negative 2, still the same slope, x minus 3. So this is pretty much close to point-slope form now. They look a lot different in point-slope form, but that doesn't mean they're different. Minus minus becomes plus plus. So you get y plus 2 equals negative 2x plus 6. Still doesn't look like this one, but then we're trying to get the y by itself, right? So we've got to subtract 2 from both sides. You get y equals negative 2x plus 4. It's the same thing, right? It's the same thing. So you don't need to do it both ways. You just need to do it one way. I just want to prove to you it doesn't matter what point you use. Now, I usually use the point that maybe has small numbers, maybe doesn't have negatives, maybe that doesn't have fractions, if one of them has fractions. So, I mean, there might be an easier choice, but they're both going to give you the same thing in the end. Okay, example 3. Write the equation in slope-intercept. So again, we're doing slope-intercept, which is what we were doing last section. But you can probably bet we're going to need to do point-slope first. So this time I'm giving you 2 points, which we've had to do problems like that before. We need to find the slope, just like we usually would. So rise over run is the change in y over the change in x, y2 minus y1 over x2 minus x1. And you call this x1, y1, this one x2, y2. So it's going to be this minus that. It's going to be 10 minus 4 over 3 minus 1. So it's going to be 6 over 2, and then that's going to be 3, and that's your slope. Now, last section, one of the points would have a 0 for the x, so we knew that was a y-intercept, and that could be your b value, and we could just plug it right into slope-intercept form, but this time we don't have that. So we need to use point-slope form first. So like I said, it might be good to write it down. Y minus y1 equals m times x minus x1. This will help you remember it also quicker. It should make it actually faster for you. So now it doesn't matter which one you use as your x1 y1. We could use this one that has x1 y1 already when I wrote that for the slope, but we could use this one too. Just because this says x2 y2, I could have flipped these in the beginning. I could have called this x2 y2 and this one x1 y1. So it really doesn't matter. Just pick one point. So I'm going to pick this first point, y minus 4. Slope is 3, x minus 1. Now that's point slope form, but we need slope intercept. So we have to continue, distribute the 3 to get rid of the parentheses, add the 4 to both sides to get rid of the subtraction. Y equals 3x plus 1. That's your final answer. Now, if you use the other point, 310, you get the same answer in slope intercept form. So, all right. Last example. Example 4. And this is going to probably look just like problems we were doing last section. Write the equation in slope intercept. So we're going for slope intercept again. And this time the information is given to you like this. F4 equals negative 2, and F8 equals 4. This is called function notation. We've dealt with this before. I would rewrite this. This is the same thing. This is your x, this is your y. So the same thing as 4, negative 2. This is the same thing as 8, comma 4. Same thing. So now this problem just looks like the last one. We got to find the slope. y2 minus y1 over x2 minus x1. So y2 minus y1, 4 minus negative 2 over 8 minus 4. Minus minus becomes plus plus, so we get 6 on the top, 4 on the bottom. We can reduce this. Divide 2 out of the top and 2 out of the bottom. We get 3 halves. That's our slope. Leave it like that. Don't write it as 1.5. Now, we need to write in, we got to start with point slope form because neither of these are the x-intercept. So y minus y1 equals m times x minus x1. We can use either point. So this time I'll use this one. That'll be my x1, y1. So y minus y equals the slope, 3 halves times x minus 8. So this is point slope form. And if the directions asked for that, you'd be done. But this time they said slope intercept. So we have to distribute. So 3 halves gets distributed to the x. 3 halves gets distributed to 8. Now you could start canceling right now if you want, if you feel okay with it. 2 goes in 2 once. 2 goes in 8 4 times. 3 times 4 is 12. 1 times 1 is 1. That's it. So what we just did, if it helps, is we did this. 2 goes in 2 once. 2 goes in 8 4 times. 3 times 4 is 12. 1 times 1 is 1. Right, there's a lot of ways you can think of this. You can say 3 halves times 8 over 1. You just multiply the tops and multiply the bottoms right away, and then reduce. 24 divided by 2 is 12. So however you do it, you can get 12. Then we got to get rid of the minus 4 by adding 4. And that's your answer. Now, maybe because this problem was in function notation to start with, maybe we need to change our answer to function notation. This is easy, but just something to pay attention to. This might be what causes you to get a problem wrong or whatever. So instead of y, we write fx. That's the only difference. This same answer, function notation. Okay? So today, for our class, we're going to do monitoring progress. And it's going to start on page 182. And there will be 6 problems, 1 through 6 all. They're at the bottoms of the pages in the lesson. And there's little blue arrows on the Student Dynamic ebook. So if you press them, it'll show you a little video that shows exactly how to do the problem, that problem. So no excuses. We should all be able to get this done, even if we have trouble. There's videos that show you how to do it. And then we'll upload our work and our notes to Google Classroom and get credit for it. So there you go. Go for it.